Okay. I was actually looking for a past paper I kept, and I wanted us to look into it 2024 past question. But apparently, I couldn't find it again. But since we did not finish what we did in our last class, we'll continue from there. Okay, we're dealing with formulas involving mass and volume, mass, volume, moles, relationships, right? And we're solving some problems on it. Okay. Now let's do more calculations involving masses. I hope you all can see my screen. Melody, um, Winner, because I know Winner was having challenge following us in the last class, maybe due to internet issues. Now we have this example here with us, and we are being the question says from the equation above, what mass of hydrogen will be produced if 7.2 gram of zinc reacted completely with dilute hydrochloric acid. And remember from our last class, I said that the first thing to do in questions like this is to have our balanced chemical equation. Since this kind of question involves one thing reacting with another, we have to have a balanced equation so that we would know what we are doing. Okay? Now, we have already been given the equation. Not all the time you'll be given the equation. But since in this case we have been given, we would now have to ensure that it is balanced. Okay? Now we see our zinc in the reactant and products are 1. Hydrogen is balanced and chlorine also is balanced 2 and 2. So that is it. And then we're told that we are looking for the mass of hydrogen. Okay, where is the hydrogen here? We are not talking about the hydrogen in hydrochloric acid. No, this is hydrochloric acid. It's making a compound. All right, so we are dealing with this hydrogen. Mass of hydrogen will be produced if 7.2 gram of zinc. Now zinc, wait, did we um solve this question in the last class? Is this something we already did? This particular question. Melody and Winner.
I don't really know.
Okay, how about you, Melody? All right, so let's just do it since Winner doesn't really know, and I believe we wasn't here the last time. Okay, moving on. If we read further, we'll see produced if 7.2 grams of zinc. That is to say, this whole question is focused on the relationship between hydrogen and zinc. So in other words, we have to really not give so much focus on hydrochloric acid and zinc chloride. That is just the truth. Because we would be relating just hydrogen and zinc to get our answer. Okay, so like the way I showed you to do it the last time, we're going to, since informations are given to us about hydrogen and zinc, Okay, so we'd say this side is for zinc and this side is for hydrogen. Now we know the mass of zinc to be 7.2, and we know the mass of hydrogen to be, we don't know it. Okay, react completely with dilute hydrochloric acid. So the reason why hydrochloric acid is mentioned is for us to know what and what is reacting to give us our product. But luckily for us, the question already gave us. So there can be a question like this where the balanced equation is not given to you. It's now left for you to do it because the question has already told you what and what is involved. The question says what mass of hydrogen will be produced. That means our hydrogen will be in the product, right? And then when zinc completely is that when zinc reacts completely with HCl. So we know that zinc plus HCl is going to be our reactant. Then we know that hydrogen is one of the things that are produced. So if that be the case, it means that the other thing that is being produced doesn't have to be mentioned in the question. We'll just have to use our common sense to know it. How? Because our product is already giving us hydrogen, but we don't have chlorine and zinc in the product. That means it's the zinc and the chlorine that is going to be formed in our product. And then the next thing to do is to balance it. Okay. So our chlorine will have to be this. Okay, when we do our crisscross method of writing ionic compounds. Okay, so this kind of reaction, actually, what does this remind you of? When we did acid base reaction, this is one of the reactions that you should know. Like it's a familiar reaction. Okay, it is the reaction between acid and metal. And one of the characteristics or properties of acids is that they will react with a metal to give us salt and hydrogen gas. Okay. And then also, this is also an example of a displacement reaction. Okay, what is a displacement reaction? It's when an element will displace another based on its priority, or let's say superiority. Okay, now these elements have to like come from the same place somehow. Okay, so for example, zinc and hydrogen, both zinc and hydrogen are metals. Okay, and so the both of them can work with each other in a displacement reaction. I'm digressing now though, we are not talking about this particular question again. So displacement reaction is where a more reactive element will displace a less reactive element. Okay, so in this reaction, both zinc and hydrogen are both electropositive. All right, but then zinc is more reactive than hydrogen. Why? Because it is higher up in the electropositive series compared to hydrogen, which is beneath. Okay, so what will happen is that in a reaction where we see zinc and we see hydrogen bonded with some other thing, zinc will kick out hydrogen and would want to bond with that thing hydrogen was bonded with. This, in this case, it is chlorine. So since our question is telling us if we had no idea of our balanced equation, if we see a question like this, and since our question is dealing with one metal reacting with hydrogen and another negative element, okay, or hydrogen bonded with some other thing, okay, a displacement reaction can easily occur, especially when that element is more electropositive than hydrogen or than the element that is to be displaced. Okay, so since um, zinc is more electropositive um positive or is higher up in the electrochemical or electropositive series, it would easily displace hydrogen, and so it's now more like kicking out hydrogen from where it's bonded with chlorine and now being with chlorine, and then hydrogen it will now stand on its own. Okay, so the electrochemical series is that series I believe I have showed you people before. Okay, this is the trend. Potassium is higher up, and then we see sodium, and then we see this is in decreasing order of reactivity or electropositivity. Okay, so we also use this series in electrochemistry. We deal with electrochemical cell. Yeah, I think that's one of the topics we should do probably maybe in the next class, we where we also electrochemical cell, electrolytic cell, Faraday laws, calculation, and things like that. And electrochemical cell, that's what I wanted to mention. Where we can also we do also make use of this series. Then we have calcium, magnesium, then we have zinc, aluminium somewhere here, iron, then we see hydrogen and some other ones at the bottom, right? So this, if you see, mm, based on what I've written now, you see that zinc is at the top of hydrogen. So zinc will easily kick hydrogen out to form a bond with chlorine, and then hydrogen is standing on its own. So back to our question. Back to our question. So since we don't know the mass of our hydrogen, okay, and then react completely with dilute hydrochloric acid. Okay, then the next thing to ask ourselves is what formula are we going to use to determine our mass? We know that mass is equals to number of mole times molar mass, right? We don't know the number of mole as well, but we know what the molar mass is. The molar mass of hydrogen. It is hydrogen 2, so hydrogen gas. So that means it's going to be 2. The molar mass is 2. Then the number of mole, we have to determine it. How do we determine it? Someone should tell me. Someone should tell me how we are going to know what our number of mole is.
M equals to mass all over.
Very good. N equals to mass over molar mass. But we are still in the same place. Why? Because we still don't know what the mass, what will now be the mass? What will be the mass? Because it's the mass that we are actually looking for, mass of hydrogen. Yes, Melody. Now it is at this point, since you already know that number of mole is equals to mass over molar mass, but then we don't know the mass because we're not given the mass of hydrogen. We were given the mass of zinc. So we cannot use the mass of zinc in place of that of hydrogen. Okay, we should not. Okay, it's because we can get an error from it. We should not directly use the mass of one as the other. No. All right. Now, like I said in the last class, there is a direct relationship between number of mole and coefficient. That is why we have mole ratio. Now, what is the mole ratio between zinc and hydrogen in this balanced equation? This is going to be a question and answer class to an extent. So to enable that everyone is following me. And since we have done some parts of this in the last class, what's the mole ratio? What's the mole ratio between zinc and hydrogen?
1:1.
Very good. 1:1. Winner, do you know how we got 1:1? Winner, we got 1:1 based on the coefficient, okay? So zinc, the coefficient here is 1, and that of hydrogen is 1. So that means we require 1 mole of zinc to give us 1 mole of hydrogen. I said there is a direct relationship between coefficient and number of mole. So if one zinc gives us 1 hydrogen, okay, it means in terms of number of mole, right? The number of mole of zinc would also be the number of mole of hydrogen. So how do we know that? We're given the mass of zinc, so it is the number of mole of zinc that we can determine. All right, a number of mole of zinc would be equal to 7.2 divided by um molar mass of zinc, which is 65. So 7.2 divided by 65. So that is 0.1. Okay. So that is to say, for 7.1 gram of zinc, we're making use of 0.1 mole. Okay, it's equivalent to 0.1 mole. So that is to say, if the ratio is 1:1, it means that 0.1 mole of zinc would also give us 0.1 mole of hydrogen. Okay, and so our number of mole, we have gotten it to be 0.1. All right. So therefore, our mass, which is number of mole times molar mass, it will now be 0.1 times 2, which is 0.2. Okay, so 0.2 gram, that would be our mass. If you notice, in this whole question, they didn't give us the molar mass of chlorine in that bracket. Why? Because we don't need it. We don't necessarily need the information of zinc chloride. We just need it for having a balanced equation. All right. We don't need the information of zinc chloride and HCl because we are not relating with it. We're only given the mass of, we are only relating between hydrogen and zinc. Okay. This is the two aspects that the question wants us to use to determine our answer. Winner and everyone, do you understand the question? The how we got our answer? Winner, do you understand? Do you understand? Winner Melody.
Yes, ma'am.
Okay. Winner, do you?
I'm just joining the class
Oh, really?
because of my network.
Oh, sorry. So, but you don't understand what's like. Is this a question that you can solve on your own? Winner. If you look at it now, do you understand or do you want us to go over it again? I was asking earlier if you understood how we got the mole ratio.
Mom,
I was asking if you understood how we got the mole ratio. And if when you're looking at this question now, if it's something you can do. Okay.
yes, ma'am.
All right. So we get our all right. We got our mass to be 0.2 gram. Okay. Look at it here. Then then we have this second question. That calculate the mass of carbon dioxide produced on burning 150 gram of butane. So now I want you people to write the balanced chemical equation for this and tell me what your balanced chemical equation is. Yeah, I'm waiting. Tell me what to write. I'm waiting for you guys. I need a balanced chemical equation for this example 3. Example 2 rather, please. Tell me the balanced chemical equation because this exam question, let's assume it did not give you. So you would have to know it. You'd have to determine it yourself. I'm waiting, and we are actually not going to leave this question. If you people don't tell me the balanced equation, at least make an attempt.
Ma, the balance equation.
Yes.
C for
Yes.
H10 plus
Oh,
5
six.
O
Sorry, say it again.
for
Okay, C4,
H10
H10,
plus 5 O2
plus 5O2.
The product cell.
Mm-hmm.
CO2
CO2
plus 3CO
plus 3CO
plus 5H2O.
plus 5H2O. Okay. All right. This is a very good attempt. So, anyone else? Okay, just you and Rina. Rina, do you want to make your own attempt? All right. So now we can see the question says calculate the mass of carbon 4 oxide produced on burning this gram of butane.
No.
All right. Burning this 150 gram of butane. Now, when we hear burning, we know it involves oxygen. Oxygen is the primary element that participates in burning. Okay, the air is made of so many things, but oxygen is what we would primarily see coming out when we talk about burning. All right, so it means that the reactant would be butane and oxygen. And when we learned about hydrocarbons, I believe, or when we learned about combustion, maybe heat of combustion, when we learned about combustion, we learned that an hydrocarbon, okay, hydrocarbon means carbon and hydrogen bonded compounds, right? Butane is an example. An hydrocarbon will bond to give us two products, and two products only. It gives us carbon dioxide and water. Now, it can also give us carbon monoxide and water. So it depends. If it is a complete combustion, it will give us carbon monoxide, which is this one that you have here, Melody. This is carbon monoxide and water. But if it is complete combustion, it will give us this first product, carbon dioxide and water. So it should be two products. It shouldn't be the both carbon monoxide and carbon dioxide present in the product, okay? So now, if we are not being told it is incomplete combustion or incomplete burning, then we would assume it to be complete burning, okay? And so for these our equation, we are going to be having carbon dioxide and water as our products only. So we don't have to have carbon dioxide and carbon monoxide again. They are both gases. So the two of them being there is it's not accurate. Melody, are you with us?
Yes, ma'am.
All right. So did you hear when I said we cannot have both carbon monoxide and carbon dioxide as our product? So our product has to be, since we're not being told whether
Yes.
it's complete or incomplete, we are going to flow with complete combustion. And so carbon monoxide is out. So our product should be carbon dioxide and water. Okay. The next thing is to balance. Now I want you all to attempt balancing this equation. Okay. Now to balance this equation so that we don't waste so much time. Now to balance this equation, we see it like this now, right? Carbon is 4 in the reactant and carbon has to be 4 in the product. And so we have only one carbon here. So we put our carbon here. Remember, when we are balancing an equation, we don't add to the coefficient. Otherwise, we are changing the whole formula of the compound. We add to to the, I'm sorry, we don't have add to the subscript. Otherwise, we'll be changing the whole formula of the compound. We only add to the coefficient. We alter the coefficient. We remove or add. Okay, that is after we have added. We can decide to remove. Right? We don't change the coefficient. Okay, because coefficient is part of what makes the molecular formula. All right. Then, so let's assume our carbon is now balanced. Then, in this kind of combustion reaction or burning, we should balance our oxygen last. All right, because oxygen is standing alone in the reactant, so it's easier to it's easier to touch it lastly that way. Then our hydrogen in the reactant is 10, and then the product is 2. So what do we have to do to make it 10 as well? Is by adding a 5 here. So 5 times 2 is giving us 10. So hydrogen is balanced for now. And then our oxygen, okay, based on what Melody gave us before. Okay. Well, let's start from beginning. Let's remove this 5 here. So this is the oxygen that actually reacts from the beginning. Oxygen gas O2, right? Now oxygen in the reactant is 2, and then the product, it is, here we have 8 oxygen and here we have 5 oxygen. Okay, and 8 plus 5 is giving us 13. It's difficult to find a number that will multiply 2 to give us 13. Okay, but then we can make use of fraction, and so we can say this will be 13, right? This will be 13 over 2. Okay, so if it is 13 over 2, it is actually balanced like this, but there is a rule that is sometimes strictly followed, that you shouldn't have a fraction for a coefficient. So an easy way for us to change this our fraction and make it um to make this our fraction to become a whole number, okay, so that we don't have a fraction as our answer, is to multiply through by 2, so that we eliminate the denominator of our fraction in our oxygen. Okay, so if we're multiplying by 2, we're multiplying everything by 2. And so when we do that, we have 2C4H10 plus, then this will now be 13. Okay, 1302. How do we get 1302? This is 13 divided by 2 times this 2 we are multiplying everything by, right? So this 2 cancelling this 2 is now just 13 standing on its own. Then to give us 4 times 2. All this 2 is multiplying the coefficient only. Leave all the subscripts there. You know what subscript is? For example, we have this H2 here. The number, the small number at the bottom that's attached to an element is what the subscript is. So we are not multiplying or changing that subscript. The multiplying through is affecting just the coefficient. And then here we have 8CO2 plus 10, 10H2O, right? So this is our balanced equation. Is anyone confused? Melody, Winner, do you all understand? So this is to tell you that sometimes you will have to, when we are dealing with mass and moles relationship kind of questions, sometimes you have to write your own balanced equation on your own. Okay? So not all the time the question will give you. The question will just drop like that. It will not even give you an update that you should write a balanced equation. So as a chemistry student, you should know what to do. Okay, so we have these as our balanced equation. It's a very big value, but the coefficients are big, but we are still going to work with it because we can't make it any simpler from this, right? Because we're having what is it called, prime numbers like 13 that we cannot be dividing it, things through easily. We cannot get a common factor there. Now, they say we should calculate the mass of carbon dioxide, okay, used in the burning of 150 gram of butane. That is, we are giving mass of butane and we are looking for mass of carbon dioxide. That is to say, the two key properties that we would use to get our answers in this question is carbon dioxide and butane. So we don't really necessarily need the information of oxygen gas and H2O. All right. So we are only relating this and this. Now, mass of this is equal to 150 gram. And mass of this we do not know. All right. Okay. And then what else? How do we find the mass? We know that mass is equals to number of mole times molar mass. Okay. And molar mass, what will be our molar mass of CO2? All these brackets is what tells us. Okay. CO2 means C plus O, right? Which is 12 plus O is 16 plus another 16, which is when I calculate 12 plus 16 plus 16, which is 44. So the molar mass of carbon dioxide is 44. So we write our 44. So this is 44. But we also don't know the number of mole of CO2. Okay? How do we get the number of mole? I'm asking this question again for the second time. How do we get the number of mole so that we can finally get our mass? Because our aim is to get the mass of CO2. And we can't get the mass if we don't know the number of mole. So we get the number of mole, okay, by the number of mole of um butane whose mass is given. And then we relate to the balanced equation. Okay, since the mass of butane is given, it's easy to find the number of mole of butane. Okay, now the number of mole of butane is equals to mass divided by molar mass, right? Which is mass is 150 divided by molar mass. What is the molar mass? Butane, which is C4A6, which is 12 times 4 plus 1 times 10, which is still 10. So it's going to be 12 times 4 plus 10, 58. So the number of mole is 58. So 50 divided by 58, 150 rather, divided by 58, okay, is 2.58 mole. Now this is the number of mole of butane. Don't get yourself confused. Now, like I said earlier, there is a direct relationship between number of mole and coefficient. Okay, the coefficient, or in our based on our balanced equation. Now, based on the balanced equation, the coefficient is what tells us the mole ratio. All right. So we need to go to our balanced equation and know what our mole ratio is. Based on our balanced equation, what is the mole ratio between butane and carbon dioxide? Yeah, someone should tell us. What is our mole ratio? Yes. Winner. All right. So the mole ratio between these two, okay. I told you it's based on the coefficient. This one is 2 and this one is 8. So it's a 2 ratio 8 something, or you can say 1 ratio 4. All right. So the mole ratio is 2 ratio 8. It means that if 2 mole, all right, not number of mole now. If 2 mole, capital M, if 2 mole of butane gives us 8 mole of CO2, okay, since it has direct relationship with number of mole, it now means that 2.58 number of mole of butane will give us how many of CO2. So this is the relationship. It's just like saying if if 15 naira gives us 2 biro, okay, it means 100 naira will give us how many biro, or 150 naira will give us how many biro, or 120 naira will give us how many biro. So that's what the relationship is there. There's a direct relationship. Okay. Now, someone should tell us what is going to be. What will now be the number of mole of our carbon dioxide? If 2 gives us 8, then 2.58 will give us how many? Remember, this 2 here is for our butane, and the 8 here is for our CO2. This is the number of mole of butane, and this is the mole in terms of coefficient of butane. So someone should tell us, please, how do you calculate this? What would be the answer? You can just tell us the if you don't have a calculator nearby, you can tell us how we're going to solve it. What times what, or is it that we're multiplying everything, or we are dividing, or what are we going to do to get the number of mole of carbon dioxide? No one knows. Hmm. All right, we're going to cross multiply. If we cross multiply, we would have um 8 times 2.58 divided by 2. So this will give us 10.32. So the number of mole of our carbon dioxide is 10.32. So number of mole is 10.32. and molar mass is 44. So therefore, our mass is going to be 10.32 times 44, okay, which will give us 454.08 gram. Okay, so at the end of the day, a lot of things depends on our balanced chemical equation. Do you all understand? Now, let us see some few questions concerning volume. Okay. Now we have this question on our screen. In the industrial preparation of triazonitrates 5 acid, ammonia gas is bound in oxygen. Okay, and we're given our balance equation, ammonia plus oxygen, to give us what? NO and H2O. Alright. Now, if 280 centimeters cube of ammonia are burned completely, what volume of oxygen is used up? Alright. And then what nitrogen oxide is produced? Okay. This time around we are dealing with volume. I remember the formula I gave for volume. Who remember? Someone should tell us in the last class. Who remembers?
But is it for gases?
Yes. I gave a list of formulas in the last class. Okay. Just as since we have concentration, one of the formulas I gave was concentration is equal to number of mole divided by volume. Okay, which also implies, look at it, constant N is equals to concentration times volume. Alright, and then volume would mean number of mole divided by concentration. What does this mean? This means that volume is directly proportional to number of mole, and volume is inversely proportional to concentration. That is to say, there is a relationship between volume and mole, right? So that is what it simply means. So that is to say, when we have a balanced equation, we can relate what the coefficient, which would represent our mole, is. We can relate it to what our volume would be. All right. And so in this question, the first one is saying if we have 280 centimeters cube of ammonia that is bond, how many how many volume of oxygen is being used? We say it's being used because oxygen is found in the reactant. And since I say there is direct relationship between volume and number of mole, so we can take the value, okay, For number of mole, in this case, based on our balanced equation, this 4, 5, 4, and 6, it represents the mole, right? It it will also represent our volume since there is a direct relationship. Okay, so we can get our volume ratio. So since we are dealing with ammonia and oxygen based on the question, they said if this of ammonia is bond, how many of oxygen? So our relationship is between ammonia and oxygen. So based on the balanced equation, we require 4 moles of ammonia to give us 5 moles of oxygen. It will mean that 280 centimeters cubed, because there's a direct relationship, just as mole and number of moles we did just earlier. I'm repeating this again. Okay, 280 centimeters cube. This is in mole, and this is in volume. Okay, of oxygen of ammonia will give us how many of oxygen. This is what it's simply asking us, and it's very easy. Like we did earlier, we are going to cross multiply. All right. When we cross multiply, we have 280 times 5 divided by 4. Because this, we multiply this, and 4, we multiply the unknown. So it's going to be 280 times 5 equals to 4 unknown. Then we multiply both, divide both sides by 4. That's how we got this top one. Okay. So 280 times 5 divided by 4 is 350. So that is um the volume of oxygen being used. So in essence, they're just asking for the volume of oxygen based on the balanced equation. And then the next one is NO2 produced. We'll go back to the balanced equation again. All right. We have 4 of 4 moles of ammonia is equivalent to 4 moles of NO2. It means that 280 centimeters cube of ammonia will be equivalent to how many NO? How many nitrogen oxides? Someone should tell us this one. Someone should solve the II for us, just as it is just as we did the first one. Just as we did this I, where we directly related the coefficient, which is mole, to the volume. Let us directly relate the coefficient of ammonia and nitrogen oxide with the volume of ammonia to get that of nitrogen oxide. So, yeah, someone should tell us. Winner and Uyi. What will be the answer? Winner and Uyi. Do the next one. Is the question II? The Roman figure 2 there. They said what would be the volume of nitrogen oxide produced if 4 ammonia gives us 4 nitrogen oxide, then 280 centimeters cube of ammonia will give us how many nitrogen oxide? That's what they're asking us simply. The 4 and 4 I mentioned now is found in the balanced equation.
But is it volume of NO produced?
Yes, volume of NO produced.
Okay, no calculator. 280 centimeter cube.
Very good. That's just it. Since based on the balanced equation, 4 moles of ammonia is giving us 4 moles of nitrogen oxide, then it means that it is equating.
It's the
It's just
same,
like
yeah.
1 giving us 1. Then 280 will give us the same thing, right? It's not like the first one where 4 is implies 5. And so we now have to use calculator to multiply and divide. Okay? So that is just it. So we would have done more, but time is already out of my hand. So that is just it. And one thing you can take note of is direct relationship and inverse relationship. Okay, so since volume is directly related to number of mole, we can we might not even need a formula to solve it. Okay, we would just know that we just need our balanced equation, and we will do relationship based on ratio. That's just all we will do. So do you all understand? Any question, please? You can ask your question now. Any question? All right, what do you want us to learn in the next class? What topic should we go into the next class? I think that's also the last class. So what topic do you want us to treat? That will be next Monday. So I want to hear from the three of you. If you don't have anything in mind now, and if you want time to think about it, please get back to me today, tomorrow, so that we would know what you want us to learn about in the next class. Or if you want us to answer some past questions, you also let me know. You can send them to me, all right, before the class. Is that okay? Mm, I'm asking the people in the class. If you have a topic in mind, let me know. Is there none? Okay, that means you probably don't have any topic of challenge. So I would come up with one in the next class. Or if you think about any before the next class, you can let me know. Or if you have a past question we should answer, I'm repeating it again. You let me know and you send it to me if it's something you can send instead. All right. Okay. I hope you all have learned something today. We Melody and Winner. I want to get your response. Uyi, Melody and Winner. Did you learn something today? Do you have a topic in mind that we should learn in the next class? All right, yes.